After finding out all the Q transformation in all kinds of situations, we find that for all cases, Q parameter can be expressed in the following form. After the transformation, Q becomes Q prime, and the Q prime can be expressed as this way. And of course, Q here is the original Q, and the Q prime is the Q after transformation. And from the expression of the Q prime, we can form a ABCD matrix to describe all kinds of Q transformation. For example, for propagation in free space, of distance d, we have learned that the Q prime is Q plus d. So the corresponding ABCD matrix can be obtained as this way. For the second situation, for Gaussian beam passing through a thin length, the focal distance of the thin length is f. The Q transformation is written like this. And we can also express it as Q prime in this way. So according to the Q prime shown here, we can obtain the corresponding ABCD matrix for the second situation. And for the third situation, for Gaussian beam reflected by a curved mirror, the radius of the curved mirror is R0. And we know that the Q transformation is Q prime, the inverse of Q prime is the inverse of Q minus 2 over R0. So the corresponding ABCD matrix can be obtained as this one. And let me remind you that the ABCD matrix of the third situation can be considered as the second situation with the focal distance f is replaced by R0 over 2. So in this ABCD matrix, if you replace the f by R0 over 2, you will obtain the ABCD matrix for reflection by a curved mirror. Okay, so we have expressed the Q transform in these three situations by using the ABCD matrix. So you can use the ABCD matrix to describe all kinds of Q transformation. Besides, and from these three ABCD matrices, you can find out that if the input is in free space and the output of the Gaussian beam is also free space, if the transformation is a Gaussian beam from free space to free space, no matter what will be in the center process, you will find out that you will obtain that the determinant of the ABCD matrix will be 1. That is, A times D minus B times C will be 1. That's the properties of the ABCD matrix. So you see, in these three situations, they are all Gaussian beam from free space to free space. So the determination of these three ABCD matrices is 1. How about a optical system formed by cascaded subsystem? The cascaded here is what you have learned. Okay, so consider that we have one optical system. The transformation of Q, the transformation of the Gaussian beam can be described by A1, B1, C1, and D1. And another optical system, the corresponding ABCD matrix is A2, B2, C2, and D2. So if we connect these two optical systems, we have the input here passing through system 1 and passing through system 2, and will be the output. Our purpose is then to find out the total ABCD matrix of the cascaded system. Suppose that at the input, the Q value is Q0. After passing through the first optical system, the Q parameter becomes Q1. And after passing through the second system, the Q parameter becomes Q2. So if you can describe Q2 in this form, then you can obtain the ABCD matrix of the whole system formed by cascaded subsystems. How to find out the ABCD matrix of the whole system? We first, from the left-hand side to the right-hand side, you can place the ABCD matrix from the output to the input. That is, from the output, we have the ABCD matrix of system 2. So we put system 2 here. And then we face the system 1. So we put system 1 here. So the multiplication of these two ABCD matrices will give us the total ABCD matrix of the whole system. Okay, so you have to place the ABCD matrix in order, in right order. From the output to the input, place the ABCD matrix from the left-hand side to the right-hand side. Okay, or from the right hand side to the left hand side, place the ABCD matrix from the input to the output. So if you have three subsystems in cascaded situation, the total ABCD matrix, if you have third one here, the third one should be placed here. Then the second one. Then the first one. Okay? From the left hand side to the right hand side, you place the ABCD matrix from the output to the input, or in the inverse way. Depends on which way you will be familiar with. And just remember that the order of the ABCD matrix should be correct to obtain the total ABCD matrix of the whole system.